As part of the course in which we talk about all the different ways things can go wrong, and I'm sure I won't cover all of them, Lesson 7 is devoted to tip imaging. So what is tip imaging? Say we have a sharp feature on the surface, and our tip comes along like this, and it's moving left to right, and it's at this point on the surface where it starts to go up and over that sharp feature. So the profile that you will get in your topography image will be roughly like this, such that your image is not an image of the sharp feature, but rather it's an inverted image of the tip. In other words, it's the smaller feature that does the imaging, and the larger feature gets imaged. Let's say you just acquired an image like this, 3 repeated shapes on a topographic image. A healthily skeptical AFM researcher would ask, do these features represent the real topography of the surface, or do I have a sharp features on the sample, and these shapes represent the tip? The best way to test for that is to withdraw the cantilever from the sample, rotate the sample by 90 degrees, and then image again. And if this image here is what you see, that is a very good indicator that those features are real. What would it look like if we rotated the sample and saw indication of tip imaging? It would look like this. We've rotated the sample 90 degrees. Note that the features, number 1 here is number 1 here. Number 2 here has become number 2 here. Number 3 here is number 3 here. So the spacing of the features has remained the same. In all cases we have this triangle, but the orientation of the features has remained vertical. This indicates tip imaging. If you're following these lessons with a friend, here's a game that the two of you can play. You can say, here's my sample, here's my tip. So, friend, how will the topographic image look? It would look like this. Each feature is still in position. We see the triangle as before, but now the features have become elongated with the same shape as the tip, this way. So you can make up some games like this. Let's return to our original slide, that of the inverted image of the tip. And after having seen these several slides on tip imaging, you might be feeling discouraged right now. But let me assure you, as a computer scientist would say, it's not a bug, it's a feature. So in other words, there are some positive aspects to this. And the positive aspect is that, say if you change your tip, and you change to a conical tip, and you run over that sharp feature again, you get, again, an inverted image of your tip. But note that we are revealing the shape of the tip. That is very useful. You can use it as a calibration method, and you can buy calibration gratings that are a series of very sharp points. Now, I do want to caution you that when you're tip imaging purposefully, you must make the assumption that the features on the surface are much, much smaller than your tip. Now, they can get worn down very easily, so I would be a little bit careful about this. But it is a good starting place, and you can have some fun with it.